Today, we're going to create this animated sheen effect that we're going to use for the moused over state of our aqua button. Let's go. All right, so last week we created this really cool looking aqua style button, and we talked about a couple of things that it needed. It needed translucency, it needed a drop shadow, and it needed states. So it needs to change when I mouse over it and when I press it. Well, today we're going to make the moused over state so that the button has an animated sheen on it when you mouse over it. Let's get started. So in order to create the animated sheen, we need to add a new subgraph node to our node library that we've been building. But we've been building this library of nodes that we can use to connect together to create all kinds of different effects. And today, we're going to create the animated sheen node. So I'm going to come down here to my shaders procedural library, and we're going to add a new folder. So I'll create a folder here, and this one is called patterns. Eventually, we're going to have a whole bunch of patterns in here, but right now, we're just going to create a new shader graph, subgraph, and we're going to call it animated sheen. And this is going to be the effect that we use to create the moused over state for our button. So I'm just going to maximize our animated sheen here, and we're ready to go. So we need to add some parameters here. We're going to add a vector 2 called UV. We're going to add a vector 2 called scale. We're going to add a float value called tilt. And we're going to add another float value called speed. And these are the controls that we're going to use to control our animated sheen. So let's bring our UVs in. Actually, let's open up our graph inspector here. For the UVs, we're going to set a custom binding. And we're going to make it UV 0 like we always do. Then we're going to bring in our UV parameter. And we're going to add a branch on input connection. And connect this up so that when our UV port is empty, we can use our default UV coordinates. So I'm just going to wire those in just like that. All right, the next thing that we need to do is to be able to control the scale of our UV coordinates. So I'm going to bring in our scale here, and we're going to multiply our UVs by our scale. All right, the next thing that we want to be able to do, I need to set a default value for scale. Let's do that. We're going to set the default to 0.25 and 0.25. All right, now the next thing that we want to do is tilt our UV coordinates. And in order to do that, we actually need to make another subgraph. So I'm going to come down here to our UV folder, right-click here and pick Create Shader Graph Subgraph. And we're going to call this one Tilt. And we'll open it up. And for our Tilt subgraph, we're going to add a UV input. And we're going to add a tilt input. This is how much we're going to tilt the UVs. So I'm going to set my UV again to use custom binding. I'm going to set my label to UV 0. And we'll drag that in. For the tilt value, we're going to set a default value of 0.25. And for the Y, just leave it at 0. Okay, and again, just like we did before, we're going to add a branch on input connection and set it up so that we have our default UV coordinates coming in if the UV node or the UV input port is not connected. Okay, so we'll bring in our tilt value, and now we're going to add a swizzle node so that we can rearrange this tilt value. We're going to swap the Y and the X, so we've reordered these. And we're going to multiply that by our UV coordinates. And now we're going to swap the Y and the X again. So I'll do a Y and X. And we're going to take this value that we've calculated here and add it to our original UVs. Just like that. And now we're going to take our tilt value and add a divide here. And we're going to divide that incoming tilt value by 2. And then we're going to subtract that value from the value that we have up here. And you can see now, I don't know if you can tell from this image, but what we've done is we've taken those UV coordinates and tilted them over. And now all we need to do is create our output. So I'm going to create a vector2 node, and we're just going to call this out. And we'll wire our tilted UVs out. And then we need to do just a couple of things to finish this off. Up here in our blackboard, we need to set the path where this node is going to be stored. And so we'll set it to procedural/UV. And then we'll come over here to our graph inspector, and under our graph settings, we're going to set the preview to 2D. So there's our tilt subgraph. And so now we need to grab our tilt subgraph and add it in here to our animated Sheen. All right, cool. So we've got our animated Sheen coming along here. So we're going to wire our multiply into the UV coordinates of our tilt. And then we're going to grab our tilt parameter and wire it into the tilt amount. And what that's going to do is allow our animated Sheen to kind of be a diagonal shape. Okay, now we want our animated Sheen to be animated. And so the next thing that we need to do is add in our move node. So if I come down here under UVs, you can see we've got move. And we're going to drag move in so that we can move our animated UVs along. So now we need the move amount. And to do that, we're going to bring in our speed. And now we need to bring in time. But I don't want to use time just as it is. I want to create a node that allows us to manipulate time in a couple of interesting ways. And so we're going to add another helper subgraph here. So I'm going to come down here to our time folder. And I'm going to right click and pick Create Shader Graph Subgraph. And we're going to call this node linear time. And we'll open that up. And so for linear time, we need to add a couple of parameters. We're going to add a float parameter called in. And we're going to add another float parameter called speed. And let's set some default values for these. So our in value is going to be time. So let's set use custom binding and set that label to time. And for our speed value, let's just default it to a value of 0.3. All right, so I'll bring in our in value. We'll add a branch on input connection and connect up in. And if nothing is connected to in, we'll just go ahead and use our time node. And now we need to bring in our speed parameter, and we'll just multiply our time by the speed. And this will allow us to control how fast the speed is going. Now there are a couple of other things that I want to be able to do with this time value. So right now we've got a pretty good control here over the time, but the time is going to increase and it's just going to keep increasing. So the next thing that I want to do here is add a fraction node, and this is going to make time go from 0 to 1. And when it gets to 1, it's going to jump back to 0 again. And so this is allowing our time to loop. And you can see that happening right here. As it gets bigger, it gets all the way up to a value of 1, and then it jumps back to 0 again. So this is looping time. And for our output, I can go ahead and set this value to a float, and I can set this one to loop. Now I can just wire this directly out, and that is our looping time value. We also want to add a couple of other output values. We're going to add a mirror value so that our time can kind of bounce back and forth. And then we're going to also add a switch value. And let me go ahead and show you how these two are going to work. So for our mirror output, what I'm going to do is I'm going to take the minimum of our fraction time and 1 minus our fraction time. And then we're going to multiply the result by 2. And let me just show you what this is doing. So our looping value goes up to 1 and then it jumps back to 0. But our mirror value, I don't know if you can tell that, but it's kind of, instead of jumping back to 0, it's going up to 1 and then going back to 0 slowly and then going back up to 1. So this is going up and down instead of jumping back to 0. So that's what our mirror time does. And then we're going to also create our switch time. And basically all we have to do for that is round our result. And this makes it either a value of 0 or 1. So right now it's 0, and now it's 1, and now it's 0. So this one's going to jump back and forth. So now we have this output here that has a loop, it has a mirror, and it has a switch. So this is a really useful node for controlling all kinds of time. We'll go ahead and save that. And, two more things that we need to do. Obviously, we need to set our path to procedural /time. And we need to set our preview to 2D. And now we have another new node in our library. So there's our linear time. Come back here to our animated Sheen and drag in our linear time. Very cool. And now we can connect up our speed to our linear time node. And now we're going to use this loop output and connect that to our move. But we only wanted to connect it to the U coordinate. We only want our Sheen, our animated Sheen, to scroll in one direction. And so the way that I'm going to do that is I'm going to add a vector 2 node here, and I'm going to connect up our linear time to the X, and we're going to leave the Y at 0. And now I can connect this to our move. And if we look at our result here, nothing is happening, and that's because our speed value right now is defaulting to 0. So let's go ahead and set a default speed. We'll set it to -0.4. Now you can see we've got some animation happening here. Okay, now at this point there's one extra subgraph that we need here, and let me show you why we need it. If I add in a swizzle node and we just take a look at our X, you can see that we've got what looks like the beginnings of an animated Sheen, and it starts coming across, but then it stops and goes back to 0. And instead of doing this, we wanted to do the same thing but repeat opposite. Or basically what we need to do is to take what we've got here and mirror it. And so I need to add a new subgraph that will take what's happening and mirror this result. So let's go ahead and make our mirror node. So I'm going to come over here to our helpers folder. And in helpers, I'm going to right click and pick create shader graph, subgraph. And we're going to call this one mirror. And I'll open it up. And for our mirror node, we need a couple of parameters. We're going to add a vector 2, and we're going to call this one value. That's going to be our input. We need a subdivisions node, and this is going to control how many times to mirror it. And we need a height node, and this is going to be a float. This is our height parameter. And let's go ahead and set the default for these. So for our value, we're going to default it to 0. For our subdivisions, we're going to default it to 1. And for our height, we're also going to default it to 1. Okay, so now we can build our mirror node. So we're going to bring in our value and bring in our subdivisions parameter and multiply these together. And now we're going to take the floor of both of these and we're going to subtract the floor from our original value. And now we're going to take the inverse of both of these and we're going to find the minimum between the two. So whichever of these is smaller, we're going to find the minimum between the original value and the inverse of the value. And now we're going to take the result and multiply it by 2. And now this is where we're going to factor in our height value. So we'll bring in our height parameter and we're going to multiply height by the value that we've created. All right, and now we're done with that one. So we're going to go over here to our output and we're going to set our output to a vector 2. We'll just call it out. And we'll wire this into that output. Now there is another kind of output that we want to be able to create. We want to create the inverse of our mirror. And so I'm going to add another output here and call it inverse. And we're going to set this value to a float as well. So for the inverse, I'm going to come over here to our multiply by 2. And we're going to add a 1 minus. And then we're going to multiply that by our height. And then we're going to subtract the height from it. And then finally, we're going to add 1 just to finish it off. And this is the inverse of our mirror. So let's go ahead and take a look at what this node does. Oh, a couple of final touches here. We're going to set this to procedural / helpers. And we're going to set our preview to 2D and save it. So let's jump back to our animated Sheen node and take a look at what mirroring does. You can see right now we've got this effect that's coming across and then jumping back to 0. But if we add in our mirror node and connect that up to value, let's see, let's connect it up here like this. So now you can see instead of going across and stopping, we've actually got a value that looks like it's looping through our effect. And that's exactly what we're looking for. So let's go ahead and connect this all up. And we'll set our output to our swizzle here. And so now we have this looping value. Because it's mirrored, we're able to go from black to white and then mirrored back to black again. And that's the effect that we're looking for. So let's go ahead and clean up our graph just a little bit. And now one thing that you might notice is that right now there's no tilt being applied. So let's set a default value for this tilt and see what that does. So our tilt default value is going to be negative 0.25. And as soon as I set this, now you can see our animated Sheen is starting to scroll across, but it's been tilted. And that is what our tilt subgraph is doing. So that's pretty cool. All right, now there are just a couple of things that we need to do. We're getting a little bit too bright here. I think it's going beyond 1 in our brightness. And so we're just going to subtract 0.5 just to kind of dim things down a little bit. And what this will also do is give us some empty spaces. So now instead of that little band of black being small, we've actually got a big gap here. So we've got this nice animated Sheen coming across, and we've got a little black gap in between. And now the last thing that we need to do, just to make sure that none of these values in the black gap are negative, we're going to saturate our result so that we can go cleanly from black to white and not ever go into the negative or go too bright. And now we can wire this value out. So we're going to select our output here, just call it out, and we'll set it to be a float value. And now we've got our animated sheen. So if we just kind of clean things up a little bit here, you can see that we've created a whole bunch of new helper nodes. And this is so cool. We created linear time, we created tilt, and we created mirror. And all of these helper nodes are nodes that we're going to be able to use in the future as we continue to build up this library that enable us to create really cool looking procedural shapes and patterns. And this animated sheen node that we've been able to create because we built these building blocks is what we're going to use to create the moused over effect for our aqua style button. So next week, we're going to continue with part 2, and we're going to go ahead and use this animated sheen that we've created today to create that moused over effect for our aqua style button. I hope you tune in for that. In the meantime, let's jump over to Unreal, and I'll show you how to create this animated sheen node there as well. All right, here we are in Unreal, and last week we made this cool looking aqua style button, but last week was only part 1. And what I said that we needed to do was add translucency and a drop shadow and some states. We needed a moused over state and we needed a pressed state. Well, today we're going to work on the moused over state, and we're not going to do the whole thing because what we're going to do for the moused over state is kind of cool. We're going to add this animated sheen effect that goes across the button. When the player or the user has their mouse on top of the button, we're going to create this animated sheen. So we're going to create a material function today that creates that animated sheen. And it's kind of a complex effect. And in the process of creating that animated sheen, we're going to create 3 other material functions that we can add to our library. If we open up our content drawer here, you can see that over the last few weeks, we've been building up this library of material functions. We've got helpers, sign distance fields, time node, some UV coordinate manipulation, and all of these material functions are the real value of these tutorial videos. So, while this button may look, beautiful and flashy, the real value that we're creating here is this library of material functions that you can mix and match and combine to create your own procedural shapes and patterns. All right, so let's go ahead and get started. We're going to add a new material function in our, we actually need to make a new folder for this one. So I'm going to right click and pick new folder. And this one we're going to call patterns. And eventually we're going to have a lot of patterns in this folder, but right now we're just going to create our animated sheen. So I'm going to pick material, material function, and we're going to call our new function animated sheen. And let's open it up and get to work. So the first thing that we need to do is bring in our texture coordinates. So I'm just going to add a texture coordinate node. This is going to be our default, but we need an input for these. And so I'm going to create an input function and connect our texture coordinate to the preview port. And we're going to call our input function UV, and we're going to set it to be a vector 2. And our sort priority for this input is going to be 0. Let's go ahead and create the rest of our inputs while we're at it. So I'm going to clone this one, and we'll bring it down here, and this one's going to be called scale, and scale is also going to be a vector 2, and we'll set scale's default value to 0.25 and 0.25, and make sure we have this use preview value as default box checked, and our sort priority on this one's going to be 1. All right, so there's our scale parameter. We also need to create a tilt parameter, and this is going to allow us to make our animated sheen kind of a diagonal pattern. So there's our tilt parameter. We're going to set it to a scalar, and we're going to set the default value to -0.25, and make sure that use preview value as default is checked. So there's our scalar input, or our tilt input rather. And then for our last input, we're going to create one called speed. This one's also going to be a scalar, and we'll set our default to -0.4. All right, so there are all the inputs that we need to create our animated sheen. Okay, so the first thing that we're going to do is grab our scale value, and we're going to multiply our UV coordinates by scale. Nice and easy, just scale our UVs by our scale input parameter. And then the next thing that we want to do is tilt our UV coordinates so that we can kind of slant them over to the side. And in order to do that, we need to create a new material function. So let's open our content drawer, and we'll come down here to our UV folder. We'll right click and pick material, material function, and we'll call this one tilt. Now for tilt, we're going to need two inputs. So we're going to call this first one UV, and we'll set it as a vector 2. And check the use preview value as default box. And we're going to bring in our texture coordinates as our default. So if our UV input port is empty, it's just going to go ahead and default to using the texture coordinates. All right, the next thing that we need is a tilt input parameter, and this is going to control how much tilt we want to apply. So I'm going to call that tilt, and it's going to be a vector 2, and we're going to default it to a value of 0.25 and 0. So there's our tilt amount. So we're going to take our UV coordinates, and we're going to multiply our UVs by the tilt parameter, but before we do that, we want to swizzle these. So we're going to add a swizzle node, and we're going to use the swizzle XY input, and we're going to output the swizzle YX. So we're going to multiply our UVs by the swizzled tilt values, and then we're going to swizzle them back. So we're going to add a swizzle node again, connect it to the YX. And now this value we're going to add to our original coordinates. And now we're going to take our tilt value and divide it by 2, and then subtract that value from the value that we've been calculating up here. And now our UV coordinates will be tilted by the amount that we've added in our tilt input. So let's go ahead and save this, and we'll put it to the test. So we're going to come back here to our animated sheen, and we're going to open up our content drawer, grab our tilt node, and connect it up. And right away you'll notice, I think we want the UV input to be first. So let's switch back to tilt, go to UV, set this UV sort priority to 0, and the sort priority of the tilt input to be 1. And now we've got our UVs on the top. That's the order that we wanted. So we're going to multiply our UVs by our tilt amount. And our tilt amount is right here. So we need to connect that up. And now let's see what happens. So this is what our UV coordinates look like before the tilt. And let's just add a saturate here so we can see what they look like after. All right, there's our tilt. It's kind of hard to tell what's happening at this point. But let's keep going, and we'll be able to tell what that tilt looks like in just a minute. All right, the next thing that we need to do is move our UV coordinates, and we're going to use our speed parameter to move them, but we need to bring in our move node. So let's come down here to our content drawer and drag in our move node, and we'll connect up our UVs. Actually, you know what? For this tilt value, I want the out to be called out instead of result. So I'm going to come over to tilt, pick the output, and we're just going to type out. And we'll save it, switch back to animated sheen, and there we go. Ah, wait, it didn't rename. So I guess we need to drag in a new one for that. There we go. Okay, now we can move our UVs, but how much do we want to move them? Well, in order to control that, we need to bring in time, And I want to create another new node for controlling time that's going to give us various ways of using time in our shaders. So let's come down here to our content drawer. I'm going to pick our time folder, and we're going to create a new material function called linear time. So we're just going to call this linear time, and we'll open it up. And to control our linear time, we need two inputs. So we're going to add a function input here, and we're just going to call it in. And this one's going to be a scalar. And we'll check use preview as default. And the default for this one is just going to be time. So we're going to connect up time to the preview input port here, so that if that input is not connected, it's just going to default to using time. All right, and then the other input we need is called speed, and that's going to control how fast our time is progressing. And it's also a scalar, and let's just default speed to 0.3, and then we need to multiply our time by our speed. So this is all pretty straightforward so far. We've got our time coming in, and then we control how fast it progresses using our speed input, which defaults to 0.3. All right, and we want to set our speed sort priority to 1 so that we get our input first and then our speed. The next thing that we want to do is add a frac node, and this is going to make it so that our time never gets higher than 1. It's going to go from 0 to 1, and as soon as it gets to 1, it's going to jump back to 0 again. So that's what our frac node is doing here. You can see it gets up to 1, and as soon as it hits 1, it jumps back to 0 again. Okay, so that is going to be our first output. So we can wire this across to our output, and instead of result, we're going to call this loop, because what's happening here is our time is looping. It goes up to 0, and then it jumps back to 1. Or it goes up to 1, jumps back to 0, goes up to 1, jumps back to 0, in a continuous loop. But there are some additional outputs that we want as well. So we're going to control time in a loop, and we're also going to control time in a mirror. And we're going to set our sort priority to 1 for that one. And our third time output is going to be called switch. So let me show you how the two of these are going to work. So for mirror, I'm going to add a 1 minus node here. And we're going to find whichever of these two is smallest. So I'm going to add a minimum node and connect up our 1 minus. And then we're going to multiply the result of that by 2. And so let's take a look at what our result looks like now. So if we look at our frac, it goes from 0 to 1, 0 to 1, 0 to 1. And if we look at our result here, what this is doing is going from 0 to 1, and then 1 to 0, and 0 to 1, and 1 to 0. So this one is kind of moving in a saw wave shape. And that's basically what we're calling our mirror. So we'll output that as our mirror time. And then for our switch, all we have to do is take the output of our frac node and round it so that it's either 0 or 1. And if we take a look at what this one is doing, you can see that it's 1, and then it's 0, and then it's 1, and then it's 0. And it's just popping back and forth between these two. So we've got these 3 different methods of outputting time. We have our loop, we have our mirror, and we've got our switch. And so this is a really useful node that we can use for all kinds of things when we need to bring in time. We can loop time, we can bounce back and forth with our time, and we can switch back and forth with our time. All right, let's save that and go ahead and add it to our animated Sheen. So we'll switch back to our animated Sheen, come down here to our content drawer, and bring in linear time. So our linear time, we're going to hook it up to our speed, and then our loop value. What we want to do is make it so that linear time is only being applied to the horizontal axis of our UV coordinates. And so in order to do that, I'm going to bring in an append vector node, and we're going to connect our looping value to A of our append. And for B, we're just going to leave that one as 0. So I need to add a 0 node here and connect it up. And so now we have our linear time happening in A, but not B. And so for our move node here, we can connect that up to the move amount, and that's going to give us our animation. So if we preview this node, you can see our animation is happening there. It's a little bit hard to tell what's going on. So let's go ahead and move on, and we'll get to a result that is easy to tell what's happening in just a minute. The next thing that we need to do is, right now our move is just happening kind of like as a pop. It's going to move, it's going to slide over, and then it's going to pop back. And we actually need to add a new node that works similarly to the mirror here for our time, but it's going to work as a mirror for our UV coordinates. So we're going to come down here to our content drawer, come over here to our helpers, and we're going to add a new material function. So here's our new material function, and we're going to call this one mirror. So let's open up mirror. And what this is going to do is allow the pattern that we created to kind of ping pong back and forth, or flip one way and then flip the other way. So the first thing that we need to do is add a couple of inputs. Our first one is going to be value, and this is the value that we want to mirror, and we're going to set it to be a vector 2. In the case of today, in the use case of today, we're only mirroring a float value, but sometimes we may want to mirror more than one value as a vector 2. So we're going to set that input to be a vector 2, and we're just going to default it to 0, 0. The next input that we need is called subdivisions, and this is the number of times to mirror it or to like wave it back and forth. And so I'm going to call this one subdivisions, and we're going to default this to a value of 1 and set it to be a scalar value. And then our third input is just called height, and it's also a default, or it's also a scalar value that defaults to a value of 1. So we're going to set this to sort priority of 0, sort priority of 1, and sort priority of 2 for our height. Okay, the first thing that we need to do in here is multiply our value by our subdivisions. Then we need to floor this value, and then we need to subtract that floor value from our original value, like this. And now we're going to take this value and use a 1 minus to invert it, and we're going to find the minimum between our original value and our 1 minus value. And then we're going to multiply our result by 2. And then finally, we're going to take our height value and multiply that in as well. And that will give us the value that we can output here. So we're going to take our output and we're going to call it out. But we also want to be able to output one additional value type. So I'm going to clone our output and drag it down here. And we're going to call this one the inverse. So this is like the opposite of the mirror that we created for the first output. And in order to create that opposite, we're going to grab our multiply by 2 here and use an invert or a 1 minus. And then we're going to multiply by our height. And then we're going to subtract our height. And then at the end here, we're going to add a value of 1. And that's going to give us our inverse of our mirror. All right, so this is our mirror value. And what we need to do now is save this and put it to the test. And we're going to test it by adding it to our animated Sheen. So we'll save it and come back here to our animated Sheen. We're going to open up our content drawer and add our mirror value in here. So here are our animated UV coordinates after our move. We're going to grab the UV raw coming out of here and wire them into our mirror value. And let's take a look at our result coming out of this. Okay, so you can start seeing what's happening here. Let's actually isolate this out. So the value coming out of here, we're going to add a component mask, and I just want the red value. So let's take a look at what this one looks like if I preview it. Yeah! Now, you see, we're starting to get something that is doing our animated sheen. We have our tilt happening here, which makes our effect tilted this way. We have our move, which is scrolling it. And then we have our mirror, which is flipping it back and forth. And that's working great. The last thing that we need to do is right now, we have this black area here, but it's just a very small band. So the way that I'm going to fix that is by adding a subtract node. And we're just going to subtract a value of 0.5. And then we're going to saturate the result to make sure that the value stays between 0 and 1. And that saturate there is going to be our output. So I'm going to connect that up to our output and just call this out. All right, well, let's preview this value here and see what we get as a result. So now you can see we've got our animated sheen. Oh, this is cool. I'm just going to zoom in here so we can take a look. You can see that our value is scrolling across. And if we take the result of this material function that we've created today and add it to our button, we can add this effect where the lighting is animated across. And we can use our scale input, we can use our tilt input, we can use our speed input. All of these we can use to control what this animated sheen looks like. We can make it animate faster, we could tilt it more, we could scale it up or down. And we have this really nice animated sheen pattern here that we can use to enhance all kinds of effects. Not only that, but now that we've built this, we also have linear time that we can use in future effects. We have tilt that we can use in future effects, and we have mirror. So we have 4 new nodes that we've added to our library. So next week, we're going to take this animated sheen and we're going to add it to our Aqua style button that we're creating. We're going to add it here, and we're also going to add pressed state. We're going to add translucency, and we're going to add a drop shadow to finish out our Aqua style button. I hope you come back for that. Anyway, thank you so much for watching today, and I hope you have a great week.